for the resistor. So right now, let's see the current and voltage relationship for the inductor. Okay, so the inductor, we put this one as J omega L. Okay, and then we have the voltage drop here, VL, and we have the current. So maybe this one I give you value. Okay, your XL is maybe a positive 5, sorry, maybe positive J5. Okay, positive J5, and the current flow is 1 ampere with an angle of 0 degrees. Okay, so right now we can calculate what is the voltage of the across the inductor. So the voltage across the inductor is just is actually I multiply with your XL, right? Positive JXL. So right now your I is 1 ohm, 1 ampere with an angle of degree 0, multiply with positive J5. And I would like to show you that positive J5 in polar form is actually 5 with an angle of 90 degrees. If you don't really confident or with me, so please try. You insert your calculator J5 or 5i, and then you convert into a polar form. You will get this value, 5 angle 90 degrees. Please try. So it's because I is right now in a polar form, so I just write down my positive JXL also in a polar form. So 5 with an angle of 90 degrees. So simply I have my voltage inductor is 5 with an angle of 90 degrees, right? Okay. So if you draw the phasor diagram between the current and also the voltage, example. So right now the current, okay, so the current here is 1 ampere with an 0 degrees. So this is your current. Okay, this is your current with a 0 degrees. Okay, and your voltage is right now so this is your voltage. The angle is positive 90 degrees. So you need to plot your voltage here. So this is your VL. Okay, so right now, as you can see from the phasor diagram here, we can say that for the inductor, okay, for inductor, voltage drop or voltage across the inductor is 90 degrees. Leading, sorry, I think is, we say is leading the current with 90 degrees. Okay. For the inductor, the voltage, this one is actually always, okay? For the inductor, the voltage will always lead the current with a phase angle of 90 degrees. I would like to remind, for the resistor, the voltage and current are in phase, okay? No phase difference. But for the inductor, the phase difference between the voltage across the inductor and the current that flow inside the inductor is always different about 90 degrees. Okay, so let's go for the capacitor. Okay, I give you another example. Okay, another example for the inductor before we proceed. Let's say the current inductor right now have a value of the angle maybe 20 degrees, for example. Okay, so still you need to calculate your VL is I multiply with JXL. So right now your I is 1 degrees, 20 degrees multiply with 5, 90 degrees. Okay, so this one you will have 5110, right? Because 90 plus 20, 110. So if you plot the phasor diagram between the voltage and the current, so the current right now is 20 degrees. Okay, 20 degrees from this axis, and this is your current, and the voltage is 5 volt with an angle of 110 degrees. So 110 degrees. 110 is calculated from here to here. So this is 110. Okay. So this is your voltage. Okay. So right now, if you look at this angle, the difference between the voltage and current is still 90 degrees, right? Okay, that is what I mean. For the inductor, the current and voltage, the different angle between current and voltage is always 90 degrees. Okay. So right now you have a capacitor here. So you have a voltage, okay, VC, and the reactance of the voltage may be J, maybe 5 ohm, for example. And you have the current. The current is 1 ampere with a 0 degrees angle. Okay, so your voltage VC is I multiply with negative JXC. Your I is 1 ampere, 0 degrees, multiply with, so this one negative J5 ohm in polar form is 5 angle negative 90. Okay, if you didn't confident, you can try negative J5, use your calculator, and then transform into a polar. You will have this 5 magnitude angle negative 90 degrees. Okay, so you will have this one in a polar form, negative 90 degrees. So I will have my voltage capacitor is 5 volt with a voltage of negative 90 degrees. Okay, so or I can write down in a rectangular form is negative J 5 volt. And in a phasor diagram, I can plot this. Okay, my current right now is 1 ampere with an angle of 0. So this is my current. And my voltage right now is 5 angle negative 90 degrees. So this is my voltage. Negative 90 degrees. So this is my voltage. So for the capacitor, as you can see, for capacitor, you can see for capacitor, the current leading the voltage capacitor by 90 degrees. Okay. So if you see carefully, for the inductor, the voltage is always leading, or sometimes, let's say, just to standardize. So usually what we, for example, our bill, TNB, the power factor, and so on. So we always referring to the current. Okay, so for the inductor, the current will always lagging. Okay, lagging meaning that behind the voltage by 90 degrees. But if for the capacitor, the current is always leading the voltage by 90 degrees. Okay. So for the standardized, so just for my write up for inductor, current lagging the voltage by 90 degrees. And for the capacitor, current is leading voltage by 90 degrees. Okay, I think that's conclude our class today for tonight. Okay.